Hello guys to another tutorial. In this case we will be learning how to create an amazing saliva effect. So please stay tuned and watch the full tutorial. This one took a lot of time. Thank you. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So hop in and have fun. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance, so if you are interested, you may have a look. Thank you. Okay guys, so welcome to another file. In this case, let's see how this looks. So I made a simple layout on how this should actually look. And the concept is very simple. Make a line, split it, and turn that into saliva somehow. So the idea here is to have some lines, as you can see, they're very nice, and have a sphere. This sphere will be animated, as you can see. We will resample these lines, we'll turn them into a polypath because we need to separate all the primitives into a polypath, and this is very important, this is key. This is very extremely key. We need to have a curve set to these two values, breakpoints, and cut all internal U breakpoints. What this is going to do is, let's select with the letter S one line, and you can see everything is selected like so. But if we go into the polypath, even though we can do this, let's try to move it with letter T. Everything is stick together. However, if we go here and we do the same after the curve, everything is split. This is very important because this will allow us to actually break all the lines. So let's do a pin and let's select with the letter S and the points these two guys. As you can see, these are the points I'm selecting. I label these as underscore selected. All of them will be on points normal because I'm calling these lines normal. You can call it whatever you want. And then on the attribute noise, we will have a value called break threshold scale. This threshold scale is very important. Let's see how it looks. So this is how it looks. Middle mouse click on break threshold scale. Basically, it is a noise we can move where the blue parts are more prompt to be broken. We're going to be multiplying this by a factor, in this case 2.4, because I wanted it to be like so. And we're going to deform all the selected parts with this. This is a sphere. This is the sphere where it's moving. And if I'm only moving the part which is supposed to be selected or pinned, this is how it's going to look. Don't worry, it's okay. We're going to move this a little bit upwards, and this one too. And we're going to use this time warp. This is very important to be on fit range with these values. Of course, this is 900 because I'm starting on 900 and I'm finishing on 111 on 1100. The same for the input and the output, and I'm interpolating cubically. This will allow me to have substeps in my simulation. We're going to have a Vellum constraint set to distance on all the points which are called normal. We are also going to have these settings. You can change it to whatever you want. It depends on the scale of the project. And when I mean by scale, I mean the actual scale. If it's 1 meter, 10 meters, 100 meters, it depends on your monster. I'm going to use a weld. The weld is very, very important. As you can see, these are the spheres. These mean that all these primitives which were previously separated are now welded. And they can break. I decided to use a threshold of 100, and this is the mask. So everywhere where this color is going to be more prompt to be broken. And the pin, of course, is where I have the selected, and I chose match animation. So let's go again. This is normal. This has to go on all the primitives, and this has to only go on the selected. When we go into the Vellum solver, and if I choose this to be a visualization, what it's going to generate is a breaking on those parts, as you can see. This is not looking like Saliva because it's not very complex, but we can make it look like Saliva. So this is only a line, and I decided to turn it into an actual B2B. As you can see, this is very nice, and I'm deleting the attributes except from these two guys, which in this case I don't have, but we will have them on the actual project. We're going to fuse the points so there are no overlaps. We are going to turn this into a polypath because they are fused, otherwise we are not going to get this full length. We're going to resample and get a curve U. If we visualize the curve U, it looks something like this. But look how it looks without the fuse. Everything is split. We need this to be fused in order to generate these attributes. So what is the SL? The SL is a value we're going to look after the fact. We're not going to look it right now. And the P scale depends on our curve view. This is our curve view from 1 to 0, from 0 to 1. So if we make the shape look somehow and we multiply it by a factor and add our SL, which is equal to 0 right now, so don't worry about it, we can get a P scale, which we can of course add some noise and do a bit from particles. Let's see how it looks exaggerated. And as you can see, if I increase the width, we can make an actual curve. You see, this is very important to make the rule effect. We can reshape this. Let's go back to normal, make it a little bit larger, and then smooth it a little bit, and then reshape it back with another erode, which we can of course increase to get these kind of strange shapes. If you don't have enough resolution, you can always increase it right here, and you will get this filled back again. Again, this is very fast and easy to do, which it almost live action. Look at this, how it looks. Very, very nice. And this is the main idea behind the Saliva project. So what I'm going to show you right now is the tools I made. I'm only going to explain this one, which is the most interesting one, but I'm also going to show you a little bit how this works. And of course, if you are in my Patreon, you will be getting, if you're on the adult Patreon, the whole 3 tools. And the most useful tool, which is this one, is going to be available for everyone, which is a young patron. So let's hop in. So to begin with, we will be needing an object or a character. In this case, I decided to choose this dragon from the Rebel Way challenge. As you can see, it's very large, so I decrease it by 100 times, so it is real scale right now. This is the scale. Approximately the head is around 5 meters long, just so you can have a reference. And then I convert this into polygons so you can see it better. And I decided to have a static mesh, and I decided to have a final shape. This is mainly because my animation, or this is only a test. Of course, you can use the actual animation, which is very nice. This is very nice, but I decided to just have a blend shape between 2 states, this small mouth and this big mouth. So this is how it's going to look. It's only going to open the mouth like so. This is my animation. So the first thing we got to do, which is the main idea behind these projects, is to grab the static. Always work on static meshes if you're going to do masks. And in this case, I'm just going to show you how these tools work. Firstly, this is the first tool, which creates some kind of nice rules, or some kind of nice rules. And of course, it works with a mask. In this case, the mask it needs is the mask called mask. We can use the attribute paint like so. If we press enter while on the attribute paint, we can select something. I'm going to select the mask, and I'm going to visualize this with this visualizer. I'm going to paint, and I'm going to paint this here. As you can see, it automatically created some kind of shapes. Of course, these shapes can be then prolonged using this tool. For example, if I output max this a little bit more, it's going to work like so, giving us something like this, more saliva. But this is not the tool I want to show you guys. It's going to be this one. How does this other tool work? This other tool works similarly. Firstly, what I'm going to do, I'm going to press Ctrl Z until I resetted my changes. There we go. This works like so. I have connections A and connections B, connections A and connections B. They are going to be connected. Point A, point B. So this is where I'm going to scatter some points. This is very easy. Just paint, update, and store. If you want to make a new value, just click here and start painting. You can change it with this option, what mask to paint. So let's move into our actual tool. These are the masks, do you remember? So we can visualize the same connections A and connections B. I did this by middle mouse click and left click here. And I decided to just use this type of shading, this type of object, because I want to have the teeth here. So what it is to click here, double click on the mesh and press enter. That way I only have this geometry. I decided to use the blend shape as the animation because I want to have this as a utility inside the tool, and I did the same, blast it out. So let's hop into the actual tool. The tool works like so. It creates a dragon and you can control how many points you have and how many connections you end up having between the rules. In this case it is a lot, so I'm going to go back to normal, and the connections are these little cubes right here. You can see they have their own points, so they can be totally deformed. So let's hop inside the tool and let's see what happens. So firstly, it looks like a lot, but it's actually very, very simple. So this is my animation. This is my static mesh and this is my animation, and I choose one frame in particular, which I like. I decide to use this value and I transfer all the masks because I didn't paint over the animation. I painted over the static mesh, which is this one. And this one doesn't have any mask, so I transferred them back in. I also added some point normals because we are going to use it later. So let's hop into the animation, which is actually not animation. Remember, this is static. And I decided to scatter some points where on the connections A, which is the top part, I'm going to show it, is this one. So this is where I am scattering on this mask. So later on, I decided to add some IDs because I do need to have each point having their own ID, and I added a little mask which we can visualize right here, and I can delete later based on the mask. This is the animation. What I did with the animation is to blast the bottom part with this. If the connections B is less than 1, hence I haven't painted there, I'm going to remove the points. You can see I'm just removing everything that is not actually painted. And what I'm going to do now is to actually have the points here, which are these ones on the geometry A. So the part on the top, this is how it's look. And I'm going to write them to the bottom part, which is this one. It looks kind of odd, but if I shitter them based on ID, and then I write them back into it, I can control how dispersed they are on the geometry. As you can tell, this looks very nice. This value is working perfectly for me. Then I'm going to grab again the geometry A, which is the top part, the points here, and I'm going to basically say, hey, what is the direction, which I'm going to transfer them with the normals from the points which are right here, which are the same points I have in here. These are the same points, just stick into the lower geometry, and they have the same ID. So if I look here, you have from 0 to 2000, and here the same 0 to 2000, so they can correlate somehow on the direction. So if I subtract the position of A to the position of B, I'm going to have a normal or a vector. I don't care if it's normalized, this is not a factor for me. So I'm going to also blur these guys so they are more uniform based on the proximity. These are the values I chose. This is the geometry B, which I decided to use firstly. I'm going to use the ray function again. And look how interesting this is. I have these points and I have this ray. These are the successful rays at the bottom. As you can see, they're dispersed. And if I don't have the normals, it's going to look kind of odd. I prefer this to be more uniform. These points on the top, you shouldn't worry about it. They're going to be deleted after the fact. I'm going to grab the animation, which is of course only the static, because I decided this has to have a rest position here. This is the best place I can have. The most uniform is the best, and the longer it is, the better. So this can be a little bit complicated. So I'm going to stop here. I'm going to follow on the left side. So these are the points. And if you go back into the scatter, look at the second option. I'm choosing to have this attribute called source prim and source prim UV. What does this mean? So the primitive number of geometry is this number, right? Imagine you have a point right here. The point is right here. I do know I'm on this primitive, but I also know that inside that primitive, I'm on these coordinates, which are called prim UB. So I can store all of those values in each point, so I can know the exact location. So this is what I have here. And one nice thing to have this is the geometry that I can grab from position A, which because it's the same geometry, I can transfer them back into a new position if the prim B is correct. This won't work if I decide to just delete a singular number. It will break all over, as you can see. So the geometry has to be the same. So I'm going back into my rest, not my rest position. This is my rest position. This is my animation. And I'm going back into my position which I want to transfer the points, which is this. And I'm saying, hey, I'm deleting based on the mask, which I created right here. Basically everything, everywhere where it's red is going to be deleted. As you can see, there is no red. And then I'm deleting based on a random number from 0 to 1 based on the points number. Since this will be ended having, once we connect the points, we are going to be having the same point number, they're going to be the same. That's why this is referenced here. So, and I also creating a new ID because I'm deleting some points, right? So having this in mind, this is the first step. I'm going to write these guys. So what I did here is after the blur, as you can see, it kind of creates a better shape once I blur everything. I decided that this is not going to work if I do that to interpolate. It's just going to go back where it belongs, the top lip. But these guys are actually on another place. They are actually the bottom. So how do we store this? We could use this hit prim and hit prim UV, but I decided to use this specs code. This specs code is basically saying, hey, over this new geometry, over this geometry right here, which I do now have points nearby, decide where I am. So grab me the first geometry, grab the position, and tell me, hey, on what primitive I am. So right now I am on this primitive if I'm like this red little dot, and where I am on the UV coordinate space, and this is the max distance. I can be anywhere. I decided to use 10. So to create these values, which is basically just going to, if I interpolate to any position, store where I am currently now nearby the primitives. So this is a very useful code. In fact, I would suggest you to actually save here. I'm going to save this preset as prim UV and also XYZ list. This is a very, very handy preset. I do recommend you to save this because you will be using it very often. Now I'm also using these values, and as you can see, now we have these two situations. So since we have the IDs here and the IDs here because they are the same point number, let's merge them together. So we can see some things. Firstly, I have some lines, but also I have some points. I could fuse them and delete them, or I could clean them and delete them. The clean option will work better. So let's use the clean option. Then I can use a resample to resample these little guys. And I should also have, as shown previously, the curve UV. So let's see how it looks. This is the curve UV, which looks very nice. And I'm using a polypath to turn all the lines into their own. I don't really know what's going on here with the curve view, but it doesn't really matter. So let's move on to the path and let's work on the next step, which is the last step before the simulation. So this is the path, and I'm deciding to add a connectivity called class. That way I can loop over each point or each primitive in this case, and I can add a new variable called selected and selected to. Basically, if the first point of a primitive is 0, it's going to be selected, and if it's also the last one, which in this case is 90, is going to be selected. So let's go into selected, and basically the point 90 is selected and point 0 is selected, so the extremes are selected. That's very nice. So we can do this for every primitive, and I do know there are other ways to actually do the selection. This is the tool I decided to use in this case. I'm also deleting everything apart from the CD and the curve view, even though I don't have any CD, but let's not worry about it. I also created a new class, and I deciding, hey, create me an SL, which is going to be the thickness later on of the line from 0 to 1. So each of these guys, if I go here, is going to have a different color, meaning a different value. And then I'm going to merge this with what? This is the second part, which is going to be the connections between the actual connections. So let's grab the path. These are the path. Let's do a connectivity again. Let's scatter some points, and let's do an attribute transfer. The attribute transfer is going to just be using the position. Why I'm doing this? Well, basically, if we have some lines here and I then want them to be connected, what I'm going to be expecting is that these lines, or maybe perhaps these points, are on top, for example here, of actual points, and this transfer is going to correct this position to where it should actually go. It's going to be hard to notice, but once I do start connecting adjacent pieces, for example these guys here, you will understand. So let's show this again, and as you can see right here, I have these sorts of points, and the connected adjacents here are going to be working with these points which already exist. Look, without how this offsetted, this should be exactly on top of it, and this is going to just fix on every single point, no matter what. It's just going to fix everything. And later on, I do have some useless geometry. All these lines that go along the other lines are useless, so we need to delete them. How? And the way to delete these points, as you can see here, is to actually use this code. This code is going to be basically choosing from point A to point B and detecting the class attribute. Remember, the class attribute is inherited from where this scatter is. If this scatter is on this value class, it's going to inherit it. So let's visualize it. Where is the class? I don't have the class. So let's not click class and let's visualize it. So we have two colors. This is one class and this is another class. And if I do the points, they are going to inherit the color. And if I connect the points, you will see all of them have one class, except the connections between the lines. So having this in mind, we can loop over each primitive and say, hey, do your points have different classes? If so, don't get deleted. So this is what I'm doing. I'm only leaving those points which do have different class values. So they're unique. If they're equal, they don't get deleted. So basically in this sign, choose vertex A, vertex B, choose the point of the vertex, and read the class of that point. So vertex, which point I am, and read the class and also read the class. This is all very simple. It's just going from a vertex to point and to points to attributes. And once I have the attributes, I'm going to compare, hey, do my cluster 0 is the same as my cluster 1? If so, get deleted. The cluster which is the same is, hey, I'm the same, hey, I'm the same, okay, let's get deleted. And then I'm cleaning and I'm resampling based on this resample is basically the same because I want to have the same density of points. So what I'm doing here is connectivity. I'm adding this random SL and I'm transferring this value right here, which is the SL, because I want to have a transition of width. Maybe this width is too big and this is too small. I want a transition. So let's merge these guys together. Let's do a break threshold, which is the same as I showed you before. These are where it can break. I'm multiplying this by a value. I'm adding some colors on the selected parts, so the extreme, so I can tell they are selected, and calling all these guys connections. I'm also fusing if there are overlaps. I'm deleting everything that are not these values because I want the curve view for later. I want the CD because I want to visualize this. I want the break threshold so I can determine what it breaks, and I also want the size. Should not be worried about this. This is only to pre-visualize some things which are not relevant at the moment. And these are our curves, so we can hop off here. You will see right now that I have other tools which are different. In this case, for instance, it highly depends on where I paint the mask. For example, if I decide to paint here, or perhaps paint the line 2, which is the length of the mask, I can actually control how long this is. It can be a very long Saliva strip. It is just another tool which I'm not going to explain at this moment because the concept is very, very, very similar. And then I'm mixing all these guys together. It's saying, hey, you don't have a cell because one of these guys doesn't have a cell, which is the guy in the middle. I forgot to add the SL here, but I'm not going to use these two, so I'm going to only use what I just did with you guys. So these are the rules, right? Then this is the mesh. As you can see, it's not moving. So let's do this following. Let's go into this. These are the rules. This is the static, and this is the blend shape. And as you can see, the idea behind this is the same. Move only what's pinned. This is exactly the same. I don't even know what this is doing. I'm going to turn this off. And I'm going to go back here. It is the same. Polypath, to resample and curve view, which in this case is turned off somehow. Why is it turned off? Because probably I do have curve view beforehand. Let's see. I just think I have it right here. Yes, I do have curve view beforehand. This is why I didn't had the need to use the curve view. Otherwise, this would be broken right here. There we go. So it is the same. I just decided to split based on different groups because this is my tool and I have other options. And I carved everything as shown before. We can only use that one and it will be exactly the same as here. I decided to also transfer because some tools can be a little bit complex. I decided to transfer these groups. In this case, I'm only using connections, and I'm basically, if I go to the points, I'm having the group connections and the group connections 1, because when I carve this out, look at this, I do have the connections, the selected, but if I go here, I do have now the same selected one, but the selected is broken. It breaks once I do the carve. As you can see, it's all broken, so I need to retransfer these groups. Let's go back to normal so I don't break everything. This is working perfectly. I have everything which is needed, the pin and the selected. In this case, the selected is not going to do anything. As you can see, it's the same. I can do selected and it won't do anything. So I'm only using the transfer attributes and I'm using the time warp and the time warp on the collider. So in this case, what is going on? So now I am going to turn these guys on again, so we can see what's going on. It's a whole mess, but if you go to the first frame, it's actually looking very nice. So I'm saying, hey, the normals have this value, then the extra has also those different values, because I'm grouping them differently. This has one group, this has another group, and this one has another. So I'm deciding to do 1, 2, and 3. This is the normal. This is called extra, and this is called connections, which is what we worked together, guys. And the same concept here, the welding. Everything is welded together, and everything that has the group selected is going to be pinned. And look how it looks once I press play. As you can see, everything is falling. This is the initial position. It's going to break some things are falling. This is only residual stuff, but it's very fast. And we are actually simulating a bunch of points, almost 50,000 points. But look how this looks. It looks amazing. And what's more amazing is the fact that I can go and post-process these lines. And how do I post-process these lines? I hop in here and we have this. It's exactly the same. This is the fuse, this is the polypath, this is resample, and I do now have the curve view again right here. I don't know if I wanted to have the curve view, let's see, because I can actually use the previous curve view. It depends on how it looks. If it looks wrong, I'm not going to use it. So this curve view looks very nice, I think. Yeah, but we can use both of these guys together. So I do have a frustum based on the camera, which I'm not going to explain right now, so I'm going to turn this off. And I am going to have this value. Basically, it's exactly the same, which is basically the SL value going to from a minimum to a maximum. And also is adding it here. And I do have this curve, which I showed beforehand. And the P scale also has a noise. This noise is actually moving, but it's not a problem. And I'm doing a BDV from particles. So this is how it looks with the original curve view, and this is how it looks if I decide to use the curve view inside the mesh. It kind of looks a little bit different. It depends really on what you want. I can have more resolution here, so it really depends on what you are looking for. So let's see what I am looking for. I don't know if this looks better. I think it looks a little bit worse, so I'm going to leave it turned off, in my opinion. And of course, the the SL works like this. Some lines are going to be very thick and adding a lot of width, like so. And some lines are going to be very, very thin. Of course, and you just need a little bit difference, not that much. But this is going to be adding a lot. So this is without, everything is the same, and this is with. So it adds like a little bit of complexity. I'm also reshaping this a little bit larger, smoothing, and reshaping it back down. For example, this could work a little better. And this is how it looks, the saliva. But you will notice I am missing something. I'm missing something on how to blend this together. So this is almost the last part, and I'm going to explain how to make the saliva mesh, which are the contacts. These are the contacts, right? It looks very nice. So I do have the saliva. I do have the mask, which I have beforehand. In this case, it could be the mask, or it could be the connections, or whatever. So this is my blend shape, which is going to be working for the animation. These are the lines, and these are the masks. So let's hop in. So I decided to delete everything right here but the mask, and I also decided to have these lines on replicate them a little bit and at a value of mask equals 1, so I can transfer this again, because I do have this mask here, which, well, I think it, yeah, but this is not showing the mask like at all. I don't know, maybe it's bugged, because the mask should be here. In fact, it is here. I don't know why this is. Oh, because I should delete everything that's not the mask. There we go. So I can add these two guys or transfer these guys together. As you can tell, I'm just deleting every other value. So I'm only escaping the mask. So I can scatter based on the mask. As you can tell, it's not going to make much of a difference, because this point replicate is getting a really large portion. Is based on these 19 points and the sphere. I'm scattering here. Am I also doing another mask to make this a little bit more complex? Otherwise, this is going to look very bad. So I'm adding this. So what is the main idea behind these points, which of course have this attribute prim and attribute prim UV? Well, the main idea is, firstly, have a velocity, so I can say where this is going, and I can create this series of interesting things. These are my points with a little bit of noise. I mean, this is the original mesh with a little bit of point, and I can decide, hey, detect the distance from these points to the saliva, and the saliva is this one, but this is the distance. And the distance is going, in this case, from 0.05 to 1.4. Let's not worry about this right now, but what we can do is to actually interpolate this so it's moving with the actual animation. And also I can remap this with these values right here. But let's have a look into the distance, and let's use this value 0.00. So let's plug this in here. This is going to be 0, and this is going to go to 0.5. So this is the distance I'm having from this first initial shape. So everything is near a saliva is going to have this. So this is useful to create a p-scale based on the distance, because I'm basically normalizing this. We can ignore this because I'm not using anything here, so let's just ignore this. And I'm removing everything that's above 0.7. In this case, well, basically nothing. But if I move this to, for example, 0.1, it's going to be deleting this one, and 0.7 is going to be deleting, well, basically nothing. So this should be, in fact, over 0.7. In this case, over perhaps 0.3, or maybe 0.1. So I'm only going to keep this. In fact, we can even avoid all these together, because it's not going to make any difference at all with the following step, which is the BDV from particles. Because if the physical is equals to the distance, and if this is actually 0, when I do a BDV from particle, this is not going to be taken into account. And this is what I'm choosing to actually drive the physical. If we go outside, we go a little bit outside, I do have this ramp reference here, and we can move it to make it larger or smaller. This is very nice, and we can reshape this, we can smooth it, and we can reshape it back again and convert it into polygons and transfer the velocities based on our points. So this is how I make the surface. But now, how do we combine these together? So even though I have the velocity here, I'm going to delete it again when I turn this into polygons. This is going to take a little bit. This is being referenced from this guy here, right here inside the BDV from particles. I'm going to use 2, so it's a little bit faster. And what I'm doing is to just grab the simulation lines, this static mesh. I'm also grabbing these polygons. The static mesh is because I want to transfer the velocities. I'm grabbing this volume and grabbing this volume too. So with all these two things, these are for the velocities and these are for the combination. I'm going to hop in, combine them like so with SDF union, convert it into polygons, basically have a velocity of 0 so I can interpolate. And I'm going to use, firstly, if I go here, the lines, and secondly, remember it has to have 10 points and a blend of 0.01 because they are small. And secondly, I want to transfer the velocity of the actual mesh. And this is how you end up with this beautiful mesh that you can render on any render engine. And it's actually very and extremely fast to simulate anything here. Look how it looks. It's amazing. I really like this concept. It's very fast and you will be able to create a lot of effects with it. Tutorial, please leave a comment, subscribe. You can even join our Discord channel. I am always there to answer mostly everything. So as always, thanks for watching.